Alright, Crewton Ramone's houseofmath.com. We're going to move up to the fourth degree here in algebra. But before we do that, let's get a handle on the names of the pieces. And you can look on the page that talks about basic concepts and the 5 basic concepts, and where it shows about 3-period lesson, because you need to do 3-period lessons so that they absolutely know what the names of the pieces are. First, we start off in base 10. So that's base 10. This is 1, this is 10, this is 100, this is 1,000, right? 10 hundreds. And this is 10,000. So we're just going over the various places, because remember, the places tell you what kind, the numbers tell you how many. So here he is comparing 1 in 10,000 and 10 in 10,000. And actually what we have there is 11 in 10,000, but he's looking at what it is. What does it mean when you say 1 in 10,000? Or 1 part per 10,000? Or 10 parts per 10,000? And there, nice pose shot where it's, look, that's 1 in 10,000. And then later on we talked about this, what would it be like, what would 1 in 1 million be? So let's take a look at that. So and there's 10 in 10,000, or 10 compared to 10,000. But now we just change the scale. Using our imagination, we can do whatever we want. So this is now 100, this is 10,000, or excuse me, this is 1,000, this is 10,000, this is 100,000, and now this is 1,000,000. So being able to show 1 in 1,000,000, well, very difficult, because now we have to take that tiny one, use our imaginations, cut it up into 100 pieces, and then one of those compared to the whole thing. But you can even see 100 compared to 1,000,000 is a very small thing, right? And you can also see change factors in scale, and you can play with this for a long time. We actually spent a little bit of time on this, but I mean, you can do several lessons on this, talking about, you know, well, here, look, here's 1, square, rectangle, square, rectangle, square, and just patterning that way. And later on when we get to x to the 4th, we can talk about that patterning again. But it doesn't have to be like that. We can take this 100 and we could make it 1 by 100. Or we could make it 1 and 10,000 long, you know, depending on what scale we're in. But there's plenty of math and thinking and critical thinking that can be developed here. Because the average American, when it comes to start big numbers, their eyes just gloss over being able to imagine big numbers. Because now we can change the scale again. What if this is 10,000, and so on, and move up the scale? That would be another thing you could do at home if you're homeschooling, or you know, in school and so forth. I mean, there's multiple lessons here. So anyway, here we just went to 1,000,000, and then we started fooling around with base x. So here I have x squared, right, which is x by x, but it could also be 1 by x squared, and we could change the, you know, dimensions of these guys too. But here's where we leave the other systems in the dust, because we stay in arithmetic. We stay with x to the 3rd. It's still just 2 dimensions, right? We don't have a cube running around. It's still flat, a geometric figure that's flat. And here's x to the 4th, x squared by x squared, right? And so he is labeling the pieces, and then we do 3-period lessons so that he knows and can count these rectangles and know what they mean, know what the symbols mean, and know what the pictures mean, or what the pictures represent, and then the symbols that we use to represent those pictures. And there is 1 compared to x, and so forth. Right? So anyway, 3-period lesson. This is show me what's this. Now, just for the fun of it, we built a big one like this. And look, we just have the rectangle, right? And then we're going to count the sides. That's all it is. And then later on, we're going to knock off this to make this factorable, or more factorable, so that both sides are factorable. But even a big one like this. So in this drawing, these represent the x to the 4ths. These represent the x to the 3rds. These are the x squareds. This is also an x squared, a stick x squared, as some students like to say. These are the x's. These are the units. And all we're doing is going to count up the whole rectangle and then fool around with the sides. And we're going to do division here. What you're going to see is division. But we could also do factoring. We could do multiplication, and so forth. And little kids, and when I say little kids, I'm talking 4, 5-year-old kids can play right along here. And for little kids, you are teaching with the algebra addition, subtraction, multiplication, division. Well, here we're just going to be doing addition because we don't have any negative coefficients. But look at this. A small child counting this, well, this is 4 plus 3, which is a big deal for a 4-year-old. This is 6 plus 1, 2, 3, 4. right? This is 3 and 4. They have to be able to count it. And then this is just a factor of 2. But can you see that you can teach a lot of math to little kids, right? And by the time they're in 6th grade, as long as they know the names of the pieces, understanding that that's a rectangle and counting the sides is duck soup. It's easy. It's not scary. Why would you wait till they're 18 or in college to start introducing them to 4th degree math? So here, we just use this symbol right here. That means rectangle. I counted out the rectangle. Look at that. 2x to the 4th. Look at all those terms. 2x to the 4th plus 7x to the 3rd plus 10x squared plus 7x plus 2. Now, I'm going to tell you one side, and all you have to do is tell me the other side. So there he is, this 6th grade kid, writing, copying the picture in his notebook, and then counting it, right? Counting everything that's in there, identifying all the parts. And then we turned it into a, see, there's his work in his book, and then here is the work on the board, and I told him one side, and then tell me what the other side is. And suddenly he's a math genius. He can tell me that this is contained in this x squared plus 2x plus 1 times. That's all that question asks. So this is the whole rectangle, and that's one side. What's the other side? Can it be that easy? Yes, it can be that easy. And you can see it. There's 1, 2x squared, 3x and 2. See, there it is. And here is x squared, 2x and 1. That's this side. In fact, anywhere along here, it's 2x, or excuse me, x squared, 2x and 1. It's there, anywhere along there. The dimensions of this rectangle. Okay. Now, we can take the one factor, this factor right here, that we saw was 2x, or excuse me, x squared, 2x, and 1, and we can take the other pieces out and factor it. There it is, factored. So we can see that the factors of that are just x plus 1 times x plus 1. But here, look, it doesn't look like a square anymore, does it? Even though x plus 1 times x plus 1 is a square number. Alright. And now we changed the problem around. We actually made it smaller so that we could factor. And now you see that we have 2x to the 4th plus 7x to the 3rd. Those stayed the same, but we knocked off an x square and a couple of the x. So we only have 9x squared, 5x, and 1. And now it's pretty simple to see that, look, did anything change? Well, what changed, the down didn't change. In other words, this didn't change, but the divisor changed, right? So we took this, divided by that, got that. There's our quotient. Here's our, what was it, dividend, divisor, and quotient, right? So there's our divisor, there's the dividend, there's the quotient. Alright, but basically all we're saying is, here's the whole rectangle, there's one side, there's the other side. And later on, when we're doing pre-calculus, we want to find out the two factors, this factor and that factor. And I changed it this way, so now I can take this divisor and factor that, because it's 2x squared, 3x and 1. Oh, there it is, factored. 2x squared, 3x and 1. The factors are 2x plus 1 and x plus 1. Now, when you're looking at this, and you don't have your hands on the blocks, it can be confusing. And I found in literally hundreds of seminars going across the country, if the people could get their hands on the blocks, these were easy. Those that just sat there and didn't get their hands on the blocks and drew little pictures and so forth, they had a pretty good understanding, but not as well as, not a great as understanding as those that actually got their hands on the blocks. And those that just watched often got lost, because they don't, I mean, there's definite power in involving more of your senses in your learning experience. Understand that. Also, can you see where autistic kids, dyslexic kids, all these other children that have disabilities, when they see that they can do this kind of math, their self-esteem goes through the roof. It's fun, it's easy, it's not hard, and they have a genuine understanding of what's going on here, right? And then older kids, man, they get mad, right? Pre-calculus students and calculus kids, when they see this stuff, it's like, oh, it can't be that easy. Really, it's this easy. And then later on, with this little 6th grader, notice how we're not showing any of the work underneath here, but later on we'll show, look, we've got to multiply this, right, times the x squared, and there it is, right there, right? Because when I take that, there's my 2x to the 4th, right? There's my 3x squared, or excuse me, 3x to the 3rd, and an x squared. When I multiply this times that, subtract. And then, anyway, you can do the work yourself if you draw it out. But for this kid, at this point, that's not the point. The point was being able to make the rectangle, identify the pieces, count the sides. And later on, we'll do more of the work. right? This was just lesson 1, so first hour. Now we take a look at that, and we can see that I have one factor and the other factor, right? We can see that 2x plus 1 times x plus 1 is this side, actually right here, and this side is x plus 1 times x plus 1. That's this side, right? So now let's do this. Yeah, there you go. So you can see there's one factor, there's the other factor. So now we've completely factored this huge polynomial down to this. Now, when we're in, if we set this equal to 0 and we're in pre-calculus, there's the zeros, and you can see that these zeros are all going to be the same, right? Now, can you see where in other systems they have a huge problem? Because if they take this and we make this into a cube, x plus 1 cubed, right? Okay, and I mean physical cube. I'm talking about a physical structure that's a cube, right? Then how do I multiply it by 2x plus 1? How do I show that? 2x plus 1 times. Very difficult. But here we have that cube, and we can show the two factors are actually broken up this way, right? Factoring by parts, they call that, right? And you can see where it comes from and understand what's going on there. All right. After that, after all of that algebra, because like I said, it's a language. Mathematics is a language. We went back and built 10s and 9s and worked on our add-ins because this kid still isn't 100% proficient with all 45 add-ins. And being able to take 7 and 5 or 7 and 8 and put them together very quickly in his head without having to do calculation on his fingers is still a bit of a problem. Not much of a problem, but still, he's not fast. Like if I ask him what 27 and 8 is, he has to think about it. But so we back down to 7 and 8 and understand that 7 wants to be 10, takes the 3 out of the 8, and we get 15. Or 8 takes the 2 out of the 7, right? There's 8, takes the 2 out of the 7, and we get 15. And now when I do 27 and 8, it's the same problem with just some 10s along for the ride, and it's easy. And we bring the calculation time and computation time down to near 0 is the idea. But mathematics being the mathematics being a language is an important concept for people to understand, that we can do all of this all at once. This same lesson with a 6th grader we were doing a second ago or a few minutes ago, we were doing 4th power algebra. Then we moved down to just addition, literally add-ins. And then we went and fooled around with cementing the add-ins again using the algebra. So here is x squared, 10x, and 16, and we get one of the add-ins. For 2 and 8 is 10, and 2 times 8 is 16. And you'll see there's some add-ins that he has to do for 11, and then there's 12 down here. And what that does is it teaches factoring, it teaches multiplication, and it teaches the add-ins all in one lesson. And, you know, compound teaching, very important. The brain wants to work very quickly. Makes it fun, easy, and accessible. The algebra is not hard if you know what you're doing and you can just count and understand that you just look at the 5 basic concepts and look at the 3-period lesson so that you can identify everything that's going on here and be able to understand that all we're doing is making rectangles, counting the sides. 0, 0, no fun, get back to 1. Numbers tell you how many, places tell you what kind. Same. And all we're doing is counting. Those are the 5 concepts, not in order, but I mean, that's it. That's all there is to the math. It never changes. So you can see here that if a child, and we have some footage that I wish we could dig up of a child, he was actually being interviewed on the news, where he got a problem like this, and he got the answer, or he got the, found out what the divisor was going to be, and gave the quotient, no problem. And people were like, wow, you got it right. He's like, yeah, I know. Of course he does, because he can see this, right? The adults don't see this picture. The kids can see it in their head, or they may make a little sketch on the side, you know, make a few lines and so forth, not the whole thing, to help them, you know, clarify their thought and get the answer. But it's really that easy when you can see this. And like I said, if you want to see how we do, you know, negative expressions or negative terms in here, as long as they are factorable and work out, you know, it's really quite simple. When you start getting, you know, these kind of things that don't have factorable sides, then it gets to be a little more difficult. But even, I mean, you know, if you have remainders and so forth is what I mean. But when you work with ones that work out perfectly to start, that's where you want to start, isn't it? Right? You want to make it easy and fun. And you can play with these to your little heart's content. You really can. There's lots of math that can be learned here. Use the algebra to teach the other mathematics. All right, Crewton Ramone's House of Math.com for more.